Okay, so let's continue. Okay. Uh, so here, okay. So we have this annual laws follow this distributing density function thus. So this density function. So this is just the this coefficient is so complicated. So this is just the density function, just like that. This equal constant c times x negative 3.5. So this is just the power function. Okay. Okay. So the insurance policy is annual deductible is 2. So what does it mean? What does it mean? What is the meaning of the loss not paid by the insurance company, insurance policy? So not paid. So let's say, so x start from 0.6. Okay, so deductible is 2. So let's say suppose it's 2. So between 0 to 2, the company will not pay, not paid, right? So this not paid is x. Okay, and then when x is the loss larger than 2, the company will pay x minus 2, but not paid is 2, right? So not paid is thus. Okay, so we want to find the mean for this. So not paid, this mean is from this part 0.6 to 2 is 0.6 to 2. So not paid is x, then density function. Okay, so plus 2 to infinity, not paid is 2. So fx dx. Okay. So the fx equals us. So this just become like, okay, so there's a constant. So fx is x negative 3.5. So this is just x negative 2.5 dx. Okay, and so here, so this fx is 2 to infinity x negative, or there's c, yes, c to c, so negative 3.5. So we can easily, for this those power function, we can easily find its integration, right? Okay. So for this density function, is just the coefficient c or like y negative 2. Yeah, so this is also a power function. Negative 3. So this is a power function. Okay, so find expected value of benefit paid under this insurance policy. So here, paid expected value for paid or pay. Okay. So what is the policy for pay? So pay is there's a policy. So has a limited of 10. So this means if y, so this y is from 1, so largest at least 1, right? So okay, so limit is 10. So above 10, so here no deductible, so they will pay this y, right? And here they will pay 10. So the benefit, the paid is just y 10. So expectation is just from 1 to 10. So just y if y dy. Okay, so from 10 to infinity, just pay 10 if y dy. So this y, this if y then the function is a power function, so then those integration is easy. Okay, so now for this problem, let's say has a deductible. Okay. And so this automobile was so much, and deductible this, and so much chance have partial damage, and so much chance total damage. So total damage losses us, right? But partial damage is can change. The partial damage depends on the situation. So there's a partial damage is a landing variable, can change. Okay, so let's see how it change, or what is partial damage. There's a partial damage. This x is follow this density function. So this is for partial damage. So this damage x can be from 0 to 15. Right? So we want to find the expected value, expected claim, expected payment. Okay, so here talking about a payment. Okay, so let's say we have like partial damage or total damage. We have two cases, right? So for damage, we have there's two damages: partial damage and total damage. Okay. So also we have a deductible. Okay, so we can put this damage. We have a partial. Let's see. Okay. So here there's a problem. So what is the chance for partial damage? Partial damage is 0.004. So 0.04 for partial damage. Okay. And how much damage? Damage is x. And the payment is we have a deductible, right? So payment actually is the maximum, like payment is x from 0 to, okay, so between 0 to 1000, this is 0, and larger than 1000, x minus 1000. So we also can use this, so we can say payment is maximum from 0 to x minus 1000. So x minus 1000, this is x minus 1000 larger than 0. So here x minus 1000 less than 0. Less than 0, we just take 0. Okay. So for total damage, probability is this, and the damage is this, and the payment is this. Okay. So once we listed all those information, then the expected payment so equals this, right? There's a probability 0.04 partial damage, the probability for partial damage, and the payment is this. Payment is, so expectation is from x from 0 to 100, 1000 0. So this is just from 1000 if x is larger than 1000, and to or actually this 1000 we just use regarded as 1. Yeah, so here in thousands, right? So we can put this as 1. So from 1 to 15, this is the x minus 1 payment, then fx dx. Okay. Then plus total damage. Total damage is 0, 0, 2. Then their payment is thus. Okay. Okay. So here we just use this integration, right? So this integration 0, 0, 4. So for integration, first thing is simplify. Okay, so there's a coefficient. We just coefficient 0.503. We put 0.5003 here. So multiply. Okay, take this coefficient outside. Saying this equal e negative x over 2, so dx. Okay, so this is easy, right? We forget. So let's say by now this becomes a math problem. We wanted to find this number. Okay. So this integration, this math integration takes some time. It seems the integration difficult. So at first we try to simplify. So let's say we don't like x minus 1. We let x minus 1 equal t. So we put this, we regard this as I. Okay. So I equals at the first this equal t. Right. So this negative x. Negative x equal t plus 1. T plus 1 over 2, right? So x is t plus 1. So then put a negative here. Okay? Then dt. Okay, so then t from 0 to 14, right? Okay. And we also can take this half outside. So let's say like negative half. So this become like 0 to 14. T is negative t over 2. And we don't like t over 2. This is t over 2. We just let, so we use substitution. We let t over 2 is u. Maybe we prefer this, we just let the negative this equal u. So this just equal u. Okay, so we just focus on this part. So this equal, let's say, so this is u. And then this t equal negative 2u, right? T is negative 2u, and dt. So here t is when t equal negative 2u, so dt equal negative 2 du. Okay. Okay. So then u. So when t equals 0, u equals 0. When t equal 14, u equal negative 7. Okay, so this equal negative. Okay, so this equal, let's say negative become positive 4. So this equal 0 to negative 7. U is negative u du. Oh no, this u is u du. Okay, so we say maybe so for integration, most difficult is just those things. X is negative x dx. Oh, x is x dx. Maybe we can regard it as a formula. Equal x is x minus x. Okay. So if AB, saying AB. Okay. So before you take, maybe before you're taking the exam, you just regard this, put this as a formula. Okay, so you don't need every time you don't need use integration by parts. You just regard it as a formula. So you can plug in. Okay. Okay. Okay, so for this one, insurance policy loss is x. Okay, so x follow uniform distribution, x from 0 to 1000. So the damage can be, the loss can be 0, can be 1000, just between 0 to 1000. So at what level must be deductible? What is the deductible should be? So let's say deductible set to here. See? Okay. So set to here. So then the expected payment will be 25% what it would be with no deductible. So no deductible. If there is no deductible, then this payment expectation for payment pay equal just half, equal 500, right? So this is without deductible. So by now with this deductible C, this payment to be 20% of this. So this 20%, 25% of this. %25 of this is, let's say, 125. Okay, so now the problem is we want to find this C such that the expected value for payment with deductible, pay with deductible equals this. Okay, so find this C. So this payment with deductible is here is 0, right? And here is x minus C, right? Okay, so this expectation is let's say equal. So here's 0. So then like from C to 1000. The payment is x minus C. Okay, then density function, this is uniform distributed density function is just 1 over 1000 dx. Okay, so there's a constant, we just take it out. And for this integration x minus dx, we can separate, but the best way is just to use substitution. We just let x minus c equal t. So this become t dt. Okay, and So t from 0 to 1000 minus c, right? Okay. So this integration, so we know this equal just half this square, right? So half this square, 1000 minus c square. Okay, so we just let this equal 1 to 5, so we can find the c. Okay. Okay, so for this problem, we want to determine the variance of y. So what is variance? You say variance of y equal ey square minus e square of y. So we need to find ey and ey square. Okay? Right? Okay. So what is y? What is x? Let's see. Y is the age of the machine at the first of replacement. So when the machine will be replaced, so let's check this. So this machine will be replaced at the fair if this machine not work, or at the age of 4, or if after 4 years we will replace this machine is too old, right? So this is why, like let's say, so the x, suppose like x is the damage, the failure. So if x can be x from 0 to 5, and this 4. So this is why if between 0 to 4, this y the failure is at the time the replace is just equal x, right? So when the machine not work, fail, then we replace. So this y, this time y is same as x. And so if machine not still can work, but we will replace. So this in here is y equal 4. Okay, so this is y, right? So let's check. So what is ey? So we want to find this ey is equal. This like if x between 0 to 4, this y equal x f x dx. Okay, so if y, so if x larger than 4, or x 4 to 5, then this y equal 4. Okay, so this fx constant 1 over 5. So such integration is really easy, right? Yeah. Okay, so for example, for this one, 0, 4, so fx 1 over 5 x dx. So this is 4, and fx 1 over 5. So this is dx. So this is really easy to find this. This is for 1 over 5. So x integrating half of this square, right? So plus, so this is just 4. Okay, so then we also need to find this y squared. Y squared So y square, so y square, so y is between when x between 0 to 4, y is just equal x. So that's equal when x between 0 to 4, y equal x squared. So fx dx plus, okay, when x between 4 to 5, y equal 4. So just equal 4 square of 16, and fx dx. So fx we already know is 1 over 5, right? So here we can easily to find those integration like this. Fx 1 over 5, so 1 over 5. So x square integration is 3 x3, so 4 3, right? So plus 5 16, yeah. Okay, so then we can find the variance. Okay, so sometimes we're talking about minimum, maximum. Like okay, so suppose we like x1, x2, we have several variables, and we let y is maximum of them, z is minimum of them. Then what is the distribution for them, for y and x? So this is the distribution for maximum or minimum. So we just check their cumulative function. So like we want to find this. So find the cumulative, then we can find the density function. Then we can find everything. Right? We can find variance, find everything. So here, this is probably y less than x. So y is maximum. So maximum less than x means everyone less than x, right? So this become like x1 less than x multiply x2 less than x. So x1 less than x is a cumulative function for x1, right? So this is just we have this result. Cumulative function for maximum is just a multiplication for cumulative function for each one. Okay, so for minimum, we have to use this minimum, smallest one larger than x means each one larger than x. So larger than x is one mod cumulative function, right? So from here we can find the cumulative function, then density function, then we can find everything, right? Once we have a density function, we can have everything. Okay. So this considers a problem. Like suppose x1, x2, x3 follow exponential distribution with mean is 1 to 3. So we want to find the minimum, maximum, find their density function. So for exponential distribution, so density function, we just remember this. Density function is lambda e negative lambda x. Okay. So this mean equal 1 over lambda. Okay. So mean is not lambda, 1 over lambda. Okay. So if mean is 1 to 3, then we can have their density functions, right? Okay. So we said like a density function is like a f1x is just equal e negative x. So density function for second one is so mean is 2, so lambda is half, is negative half. So this mean is 2. And that one is 1 over 3, is negative 1 over 3. Okay. So for exponential density function, exponential distribution, we have thus: if x is equal 1 minus negative lambda x. And this one, like larger than x, so equal negative lambda x. Okay, so cumulative with the left side less than. So sometimes we call this function survive function. So larger than is thus. So for those things, you had better to remember them because those exponential distribution or exponential function is also important. So here for integration, essentially we can only do two things. One is power function, the other one is this exponential function, right? So we will meet them frequently. So we try to remember them, then we can save some time. Okay, so now suppose we want to find density function of y. So at the first, we find cumulative function for y. Let's see, like this y less than this small y or small x. So y is maximum, right? Y is maximum, means each one x1 less than x, x2 less than x, right? So x1 less than x is the 1 minus negative x, then times 1 minus negative half x, and 1 minus negative 1 over 3x. Okay, so this is fx for y, for maximum. Okay, so this density function is just the derivative. Okay, so this function is derivative. So for minimum, we say for minimum, we say like let's say for this one, z larger than x, so smallest one larger than x means each one larger than x. So for this one, so just equal to x1 larger than x, x2 larger than x, right? So x1 larger than x equal negative lambda x. So lambda is 1 x. So here is negative half x, then is negative 1 over 3x. Okay, so this density function is just the derivative for this, but 1 minus this. Okay, so cumulative is 1 minus. So let's say, so density function. I'm sorry, density function for z. So equal. Let's say put them together. Is negative, just 1 plus half plus 1 over 3. Let's say. So 1 plus half plus 1 over 3 equals 6. 6 plus 3 plus 2, right? So this equal 11 over 6. 11 over 6x. Okay, so then the function just the 11 over 6 is negative 11 over 6x. Okay. Okay, so now there's a problem is what is the expected value of the largest of these three claims? So largest, the maximum of these three. So we have like x1, x2, x3. So we find the maximum of them. So suppose this is y. Okay. So the question is find the expected value for this y. We just need to find y. Okay. Okay. So to find this y, we need to know the density function for this y. Okay, so we need to find the density function. So we say this is just equal according to formula just y if y dy, right? But here at the first we need to find the density function for y if y, the density function of this y. We want to find fy. So in order to find this density function for y, so we let's say we just check the cumulative function y less than y. So y less than y means like largest one less than this number. So means each one less than this number. So equal, so like x1 less than y, and x2 less than y, x3 less than y. So this x1, x2, x3, we say those things follow the same density function. So this just equal, we can say this equal if this if x3's power, right? So each one, I'm sorry, we can use y, if y3. So what is if y? So if y so equal the cumulative function for until y. So this equal okay, just from okay y if x dx. Okay, so this x is at least 1, right? So here's 1, so y is positive here. So we need to find this. So actually this integration is from 1 to y. Then if x is 3x negative 4dx. So we can find its integration. So 3x4 is x negative 3. X negative 3, right? Yeah. So x negative 3, but it's a negative. So this is x negative 3. But we have, yeah, so from 1 to y. So this equal, so plug in, so x and y negative 3, so y 1. So this equal 1 minus y negative 3. Okay, so this, so here become 1 minus y negative 3's power. Okay, so then we plug in here the density function. Oh, we need to use the derivative. So if y, so if y, so this if y is equal, this derivative equal 1 minus y negative 3's derivative. Okay, so so here this just become math problem, right? So there's a derivative equals 3, 2, and there's a derivative y negative 3 derivative equal negative 3 y negative 2. Okay, say negative 1. So this equal 9y negative 2, 1 minus negative, okay, like this, equal 9y negative 2, then 1 minus negative 3, 2. Okay, so then we can go back to the problem, to the problem. So if y equals this, then become integration. So multiply y. So this become, let's say, so this ey finally, ey so equal this integration. So 9. So multiply y become y negative 1. Then 1 minus y negative 3 square, so dy. And then what is the lower bound, upper bound for this integration? So let's say, so this x at least 1. So this y is also at least 1, right? So this y so equal so 1 to infinity. Okay. So this become this integration problem. We want to find the integration. Okay. So here the integration. So this is just a power function. So we can expand, right? We just use square. So let's say, okay, 9. So 1. Okay. So this square. So this is first one y minus 1. So this is negative 2. So here 2y 2y negative 3. So y negative 4, right? So plus, so this square y negative 6. So y negative 6 negative 7. So dy. Okay. So let's say, so for this, like we say y negative 1, so let's say how about y negative k dy. So this equal what? This is just equal negative k plus 1. So y, yeah, so this just equals this. No, negative k, should it negative 1, yeah. So this equal just the equal k minus 1. Okay, so we can plug it in here. So we can get the final answer. So final answer is equal 9. So here negative 1. Now k, let's say k equal 1. Oh, no. We have some problem here. If k equal 1, this integration y negative, this become infinity. So here we made some mistake somewhere. No, let's say square 1 6 3 6 3 6. Okay, but I don't want to check it, so you can have a check for us, okay, where we made a mistake, but the basic idea is same, okay, negative, okay. Okay, so for this one, let's say, what's the question? Determine the probability that the maximum. So here also maximum, so we let this y is maximum. Maximum is larger than 3. So we want to find this probability, right? We want to find this. So what is y? Y is maximum of this 3. x1, x2, x3. Right? So y larger than 3, maximum larger than. So for maximum, we just consider we should use less than, right? Maximum less than this, the largest one less than this, then each one should less than this, right? So for this probability, we just use this 1 minus y less than. So y less than means the each one less than. So that's equal p. So first one less than 3, second one less than 3, and third one less than 3, right? Largest one less than 3. So this means each one should be less than 3. So how can find x1 less than 3, x2 less than 3? So this x1, x2, all those follow exponential distribution. Okay, so let's say for exponential distribution, let's say suppose the density function is lambda is negative lambda x. Then for this x less than a equal 1 minus negative lambda a. We just remember this. Okay, so now what is x1? So x1 mean is 1.0. So this means lambda equal 1 over 1.0, right? So second one, mean is 1.5. No, mean is 1.5. So lambda is 1 over 1.5. And the third one is 2.4, so 1 over 2.4. So those are lambdas. So we can plug in here, equal 1 minus, this probability is 1 minus negative 3. Okay, then 1 minus negative lambda is 1 over 1.5 times 3. And here 1 minus negative 1 over 2.4 times 3, or just 3 divided by 2.4. So you can find it. Use your calculator, you can find this. Okay, so those are some topic for one variable continuous distribution. So continuous distribution just involves integration. As for integration, we just have a power function and exponential function. Okay, so we stop here.